today's topic, that is electrochemical series, right? Now in the previous lectures, what have we done? We have done the electrolytic cell, then we did the electrochemical cell, right? And when we were doing the Nernst equation, we were calculating one value which was known as the standard electrode potential value. Depending upon the values of the standard electrode potential values of various metals and non-metals, this series, the electrochemical series, it was designed. Now when we are talking of electrochemical series, it is what? You can write down. It is the series in which the ions are arranged. Series in which the ions are arranged on the basis of the values of their standard reduction potentials. Standard reduction potentials. So when we are talking of the electrochemical series, let's say that we are drawing it in the form of a table. So we have the element, we have the electrode potentials, right? And then we have the, you can write down over here the electrode reaction, and over here we get the values for E0. Okay, the first element on the top of the series, that is lithium. Now lithium, the electrode reaction over here, that is going to be, instead of potential, write reaction. Electrode reaction. So the electrode reaction over here is that Li positive plus 1 electron to give us lithium, and the E0 value is minus 3.05 volts. The value of lithium is the most negative value of the reduction potential, right? Then after that, after lithium comes potassium. Reaction is going to be 1 electron to give us potassium, and the E0 value, that is minus 2.92 volts, right? Then the next is calcium, Ca2 positive plus 2 electrons to give us calcium, and the value, that is minus 2.87 volt. Okay, then after calcium comes sodium, to give us sodium, and the value is minus 2.71. Minus 2.71 volt, right? After sodium is magnesium, Mg2 positive plus 2 electrons to give us magnesium, and the value, that is minus 2.37 volt. Then after magnesium is aluminium. Al3 positive plus 3 electrons to give us aluminium, and the value, that is minus 1.66 volt. Okay, then aluminium ke baad comes zinc, and the reaction is Zn2 positive plus 2 electrons to give us zinc. The value means over here is minus 0.76 volt. Okay, then after zinc is chromium. So I am going to rub this. Okay, so after zinc comes chromium, and the reaction of chromium is Cr3 positive plus 3 electrons to give us chromium. The value is minus 0.74 volt. Okay, after chromium is iron, Fe2 positive plus 2 electrons to give us iron, and the value of iron, that is minus 0.44. Minus 0.44 volts. Then after iron is cadmium. Cd2 positive plus 2 electrons to give cadmium, and the value of cadmium is 0.40 volt. After cadmium is nickel. To give nickel, and the value, that is minus 0.25 volt, right? Nickel के बाद we have tin. Tin, Sn2 positive plus 2 electrons to give us Sn, and the value over here, that is minus 0.14 volts. ठीक है? फिर tin के पास we have H2, 2H positive plus 2 electrons to give us H2, and this is the center with a value of 0.00 volts. Okay, so hydrogen, that is taken the midpoint of the electrochemical series, where the reduction potential over here, that is going to be 0, so the value of hydrogen is taken to be standard. After the values of hydrogen, the positive values of reduction potentials, they are going to begin, right? Like after hydrogen is copper. So you will also see that there is going to be this thing, change in the signs. So over here, the value, that is plus 0.34. After copper is iodine. Iodine, and over here plus 2 electrons to give 2I negative, and the value over here is 0.54 volts, right? So this is also value in positive. Then after iodine is silver. After iodine, it is silver, Ag positive plus 1 electron to give Ag, and the E naught value is 0.80 volt. Right? After Ag is Hg. To give us Hg, and the value, that is going to be equal to 0.86. So you can see that the values of the reduction potentials have now started increasing, right? Then after Hg is bromine. To give 2Br negative. And the value, that is going to be equal to 1.08 volt, right? After bromine is chlorine. And the value is 1.36 volts. After chlorine is gold. And the value over here, that is 1.47 volts. Okay, and certain this thing 1.50 is also written. So you can take it as 1.50 volts. Then last is fluorine. Fluorine. To give us 2F negative and the value that is 2.87. So if you're looking at the electrochemical series over here, we are seeing that the values, they are coming from negative in lithium. In case of lithium, the value is minus 3.05, and then reaching the zero value of hydrogen, and henceforth taking into consideration the positive values, and the highest positive value is that of fluorine. So we are starting from a lower reduction potential to a higher reduction potential, starting from negative to 0 to positive. Now this electrochemical series has varied applications when we are talking of in chemistry. So let's go on to the applications of electrochemical series. Applications of electrochemical series, right? Now when we're looking at the we can say the applications of electrochemical series, the first application, that is reactivity of metals. According to the electrochemical series, it is seen that the metal which has higher tendency to lose electrons, that is going to be more reactive, right? So we are saying that the metal which has higher tendency to lose electrons is more reactive, right? For example, when we are talking of the, according to the electrochemical series, all the metals having higher value of negative reduction potentials, higher value of negative reduction potentials are more reactive. So if you're looking at the electrochemical series, just flip over to the page of the electrochemical series. If you're looking at that, the most negative value is that for lithium, right? Now although lithium has a higher ionization energy, we know that the tendency to lose electrons depends upon what? It is going to depend upon the ionization energy. If the ionization energy is low, the electron can be easily removed. But in case of alkali metals, the lithium is the first metal of the group. Okay, so as a result, its ionization energy should be very, very high, isn't it? But still, lithium has the highest value of reduction potential. Why? Because when we are talking of the values of reduction potential, it will not only depend upon the ionization energy, but it also depends upon the hydration energy. So sum total of both ionization energy and hydration energy, that sets the value for reduction potential. In case of lithium, we say that although the ionization energy is high, but at the same time the hydration energy of lithium and the ionization energy of lithium, when they are clubbed together or they are added together, they give us the highest value of lithium, which we will also, you must have also studied in your 11th S block elements, right? So we are saying that metals which have higher value of reduction potential, they are going to be chemically more reactive. Their reactivity can be shown as they react with even cold water to evolve hydrogen. To evolve hydrogen. Okay? Then metals like Fe, they have low negative value of reduction potentials. Lead, tin, nickel, cobalt. All of these, they have less negative value of reduction potential. As for example, when we are talking of iron has a reduction potential of minus 0.44, right? In a similar manner, if we are taking the value of nickel, it is plus 0.25, minus 0.25. Okay, so they have less value of negative reduction potentials, so they are known as less active metals. They do not react with cold water, but they are going to react with hot water due to their less activity. Then there are still metals like copper, which has a positive value of reduction potential. It is 0.34. Similarly, Ag, which has a reduction potential of 0.80 volt. Such metals, they are going to be less reactive than hydrogen. They are very low on reactivity, right? So as a result, these metals do not react with water at all. These metals do not react with water at all. Okay, so depending upon the reactivity of the metals, we have classified the metals into three. The first one is metals which have the highest value of activity because of high negative reduction potential. So if you get a comparison question in this, they have given you the values of the reduction potentials of say 3 or 4 metals, and they tell you to arrange them in order of increasing activities. So you have to remember, the higher negative reduction potential value will make the metal more reactive, and lower will make it less reactive. Okay? Then the second is electropositive character. Electropositive character. Now when we are talking of electropositive character, all those metals which have a value of minus 2.0, all those which have a value of minus 2.0 volt or more negative than this, they are strongly electropositive. They will readily leave their or remove their electron to go into electropositive state, right? So all those which have a value from 0.0 to minus 2.0 electron volt or 2.0 volt, these are moderately electropositive. We have iron. Iron has a value of 0.44. Then we have aluminium, zinc, right? All these, they are moderately electropositive. Then metals which are below hydrogen, that is the metals which have positive values of reduction potentials. As in the case of copper, which has a value of reduction potential of 0.34, these are weakly electropositive, right? So we again have categorized these are going to be weakly electropositive. We have categorized again the elements into strongly electropositive, moderately electropositive and weakly electropositive. Strongly electropositive will have values of reduction potential as minus 2.0 to higher negative values. Then moderately electropositive, anything between 0 to 2, minus 2, and positive values, they are going to be weakly electropositive. right? So this is the second application of electrochemical series. Let's go on to the third application. This is very important application, displacement reactions. Displacement reactions. We have studied in junior classes that whenever a reaction is taking place in which a metal is displacing another metal or a non-metal is displacing another non-metal, those reactions, they are known as displacement reactions. When some metal is taking the place of some other metal, that is what displacement is. So over here we are going to study three categories. The first one is displacement of metal by a metal, right? Now when we were doing the galvanic cell, we had done the reaction Zn plus CuSO4 to give us Zn SO4 plus Cu. This was the reaction of the galvanic cell. Okay, now in this we know that the E0 value of Zn2 positive to Zn, that is equal to minus 0.76 volt, right? And that for copper, that is 0.34 volt. Okay, now when we are correlating both these statements, we are looking at the reaction. The reaction says that copper is being displaced by zinc. Zinc is taking the place of copper over here. Okay, now the reduction potential value of zinc, that is minus 0.76, and that of copper, that is 0.34. These values tell us, when we had done the previous application, these values tell us that zinc is more active. It's a more active metal than copper. Therefore, it is taking the place of copper. So all those which have, all the metals having a higher negative value of reduction potential, they can easily displace the metals having either lower negative value of reduction potentials or a positive value of reduction potential, right? So an example which we can, another example which we can take over here, the type of questions which come to you is, we are taking a reaction Ag plus, say, ZnSO4. So your question is whether the reaction will take place or it will not take place. How do you manipulate such kind of questions are that when we are talking of value of E0 for Ag positive to Ag, it is 0.80 volt. Okay, and for zinc it is minus 0.76 volt. Okay, now according to this reaction, zinc has to be displaced by Ag. The value of Ag, that is 0.80, which is positive, and the value of zinc is negative. So would this reaction take place? No, it will not take place, because metal जिससे हमको displace करना है, उसकी value जो है, that is greater, that is positive, more positive. And what we are saying, only those metals can displace which have a higher negative value of reduction potentials. Okay, so those metals only can displace. So this is one important question which can come. Then second, we have displacement of non-metal by a non-metal. Displacement of non-metal by a non-metal. Let's illustrate this also with the help of an example. We are taking one equation Cl2 plus 2Ki to give us 2KCl plus I2. Okay, so now if we are looking at the reduction potential values, the value for chlorine that is equal to 1.36 volts. Right? And that for iodine is equal to 0.54. volts. Okay, so according to this reaction, iodine is being displaced by chlorine, right? And over here, the higher value is that for chlorine and the lower value is that for iodine. So when a non-metal is displacing a non-metal, only those non-metals will be able to displace which have higher positive values of reduction potentials. Have you understood the difference between the two now? When we are talking of metals displacing metals, so the value of the reduction potential should be more negative for the metal to displace, while if we are talking of non-metals displacing the non-metals, then it should have the higher positive value of reduction potential. Right? In a similar manner, there are certain reactions in which we say that hydrogen is to be displaced. Like if we are reacting metals with acids, hydrogen is evolved. Okay, so in what cases hydrogen would be evolved? So this is the third case study which we are going to do. Displacement of hydrogen from dilute acids. By metals. In this case, we can note down that all the metals which have a negative value of reduction potential, they all will be able to displace hydrogen because they are more reactive than hydrogen. Okay, but all those which have a positive value of reduction potential, they are less reactive than hydrogen. Therefore, they will not be able to displace. As for example, if we are taking say zinc plus sulfuric acid. So zinc has a negative electrode potential value. Therefore, in such cases, hydrogen gas would be evolved when we are reacting the metal with acid. Okay, but in a similar reaction we are doing with copper, the reaction does not take place. Right? So the reaction over here is not going to take place. Why am I again and again taking the example of zinc and copper? Because these are the two simple metals which we have used in the galvanic cell, and we know the values of both these by heart. Right? So this comparison study will also follow for other metals. For example, if you are doing it with Na, Na also has a negative value of reduction potential. So Na when reacts with H2SO4, it is going to give us Na2SO4 plus H2. So hydrogen is displaced even in this case, as sodium also has a negative value of reduction potential. Okay, then one very, very important application of electrochemical series is the prediction of oxidizing and reducing nature of metals and non-metals, of course. Prediction of oxidizing and reducing nature of elements. When we are talking of oxidizing and reducing agents, we have to remember one small sentence, that all those which have higher value of negative reduction potential. All those which have higher value of negative reduction potential are better reducing agents. Right? As for example, if we are comparing lithium with a value of minus 3.05 volt and that of potassium minus 2.92 volts. Okay, so in this case you can see that lithium has a higher value of negative reduction potential, so lithium is going to be a better reducing agent than potassium. In fact, lithium is the best reducing agent. Okay, so as the negative values keep on decreasing, the reducing power will also keep on decreasing. Right? So if we are comparing potassium with zinc, minus 0.76 volts. So in this case, both of these are going to be better reducing agents than zinc. Have you understood? Okay. In a similar manner, I am putting one more statement. More the positive value of reduction potential, more the positive value of reduction potential, better will be the oxidizing agent. Better will be the oxidizing agent. So if we are comparing copper with a value of 0.34 volt and we are comparing fluorine with the value of 3.0 volt. So fluorine is going to be a better oxidizing agent. Okay? So in fact fluorine is the best oxidizing agent. In other words, we are saying that when we are traveling from lithium to fluorine, we are traveling from a range of reducing agents to oxidizing agents. Okay? So as we keep coming down up to hydrogen, the oxidizing power keeps on increasing, right? And then from hydrogen we are traveling to fluorine, again the oxidizing power is increasing. But on the contrary, if we are traveling from fluorine to oxygen to lithium, the reducing character that is going to increase. Okay? So this is very important with respect to your questions. Then we come to the thermal stability of metallic oxides. Thermal stability of metallic oxides. It is said that all those metals which have a positive value of reduction potential, their oxides, they are not stable. Okay, so all those which have a positive value of reduction potential, as for example, if you are taking silver oxide, the value of reduction potential of silver, that is what? Plus 0.80, right? So when we are decomposing it or we are heating it, it is seen that it decomposes to silver and oxygen. Right? Similar is the case with mercury. Mercury also has a positive value of reduction potential. So mercury oxide right? But all those metals metals which have a negative value of reduction potential, their oxides are quite stable. As for example, if you are taking barium oxide, or we are taking sodium oxide, or we are taking aluminium oxide, all these, they do not decompose on heating. So they are stable oxides. They are going to be stable oxides. Is it clear? So what did we say over here? All those which have all the metals having a positive value of reduction potential, their oxides are unstable. When heated, they get decomposed into their metals, whereas all those which have a negative value of reduction potential, they do not, their oxides are quite stable and they do not get decomposed. Clear? Then another very important application is product of electrolysis. This is very, very important, because this is another kind of question which we generally get in either your MCQs or also for your boards. Okay, so product of electrolysis. In fact, this kind of a question has come in your boards for the past 2-3 years. It has been coming. So how do we predict the product of electrolysis? Sometimes so happens that we are taking aqueous solutions, right? And in that case, we are yielding 2 cations and 2 anions. This you've done in your electrolysis, right? We are yielding 2 cations or we are yielding 2 anions. So when we are doing that, in that case, for example, let's take the electrolysis of aqueous NaCl, right? So when we are doing aqueous NaCl, that is going to decompose into Na positive plus Cl negative, right? In a similar manner, because it is aqueous, so water is also going to decompose into H positive and OH negative. Okay. Now you can see over here that there are 2 ions which are cations which are yielded. So at the cathode there is going to be a race between both sodium and hydrogen. So at cathode, what is going to be liberated? Let's see. We have Na positive plus 1 electron to give us Na. In a similar manner, H positive plus 1 electron to give us H, and H plus H to give us H2. In this case, the prediction is favored by the values of electrode potentials, right? So if we are taking the electrode potential of sodium, that is minus 2.71. So the E naught value for this reaction is minus 2.71 volts, right? Whereas the E naught value for this reaction, that is 0. Now over here, the element which is having higher value of reduction potential, that is going to be discharged. Clear? Which has higher value of electrode potential, that is going to be discharged. So in this reaction, sodium is not going to be deposited at the cathode. Okay, so if we are taking the cations alone, according to the electrochemical series, the increasing order of you can say deposition at the cathode, that is going to be this. Potassium सबसे कम, calcium, magnesium के साथ बाद we have okay, calcium, magnesium के बाद we have aluminium, zinc, Fe2 positive, and then H positive, Ag positive and Au3 positive, right? Then in case of anions also, over here you can see that there is Cl negative and there is OH negative. So chlorine has an electrode potential of how much? It is, कितना था chlorine का 1.26. Electrode potential for chlorine, that is 1.36. Okay, so the value of chlorine over here when we are looking at the anode पे reaction हो सकती है chlorine, right? So the value of chlorine, that is 1.26. So that is going to be, which is having low value of reduction potential. Over here we are saying which is having high value of reduction potential. Over here at anode, that will be liberated, which has low value of reduction potential, right? So order इसका क्या है? We have SO4 2 negative, उससे ज़्यादा is going to be NO3 negative, more than that is OH negative, more than that is Cl negative, right? Or Cl negative से we have greater than Cl negative is Br negative and I negative, right? So this is the comparison of the products which is going to be liberated at the anode and the cathode while we are doing the electrolysis. Okay, so this is your electrochemical series. Then whatever we have studied over here, let's just take a recap and put down the points of characteristics of electrochemical series. Characteristics of first characteristics of electrochemical series. The negatives, you can write down the negative sign of standard electrode potential. Standard electrode potential indicates that electrode with joint with sheet acts as anode. So, if we have a negative reduction potential and we are connecting it with sheet, the electrode acts as anode. Whereas, if we have a positive value of electrode potential and we are joining it with sheet, it is going to be at the cathode. So if you are taking zinc plus sheet couple, zinc will be at the anode at the left hand side, and if we are taking a positive potential of say copper, then copper would be taken at the right. That is the cathode. Okay. Then second, all those metals or elements having negative values of reduction potentials are good reducing agents. Okay? Whereas all those elements having positive value of E0, they all are good oxidizing agents. ठीक है? Then number 3, all metals placed above hydrogen, that is, all those having negative values of reduction potential, they all are active metals. Okay? Whereas all metals which are placed below hydrogen, they all are less or weakly active or inactive metals. Right? So today we are going to do only till here. A little portion of this chapter is left, which is going to constitute of corrosion and cells. So I guess in the next lecture we should finish this chapter. Okay?